Good morning, children. Today we will solve some numericals of exercise 2.2. Yesterday we have discussed about the zeros and the coefficients of a cubic polynomial. Now exercise 2.2 question number 1 given, find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficients. What is the question given? Find the zeros of the following quadratic polynomial. You have to find the zeros first and then verify the relationship between the zeros and the coefficients. I think all of you have understood what we have to solve or what we have to prove. Now question number 1 given, p of x is equal to x square minus 2x. This is the question. So what you have to find? You have to find the zeros of the quadratic polynomial a square minus 2x minus 8. Now how we have to find the zeros? Now put p of x is equal to 0. P of x means a square minus 2x minus 8. Therefore, a square minus 2x minus 8 is equal to 0. Now, splitting the middle term. Now, you have to find two numbers whose product is minus 8a square. Product is minus 8a square and sum is minus 2x. So, you have to find two numbers. Splitting the middle terms means you have to find the two numbers. The product is, this is the product is a square minus 8 is equal to minus 8a square and sum is minus 2x. Now the two numbers will come 4x, 2x. 4x into 2x is equal to 8x square, but it is given minus. So if I will do this one minus, so then this will be minus 8a square. And if I write 4x into 2x, this one, and sum will be, what will be sum? Sum will be minus 4x plus 2x is equal to minus 2x. Coming or not? So, product is coming minus 8a square and a plus sum is coming your minus 2x coming. So, two numbers are which now minus 4x and plus 2x. Now, you can write a square minus 4x plus 2x minus 8 is equal to 0. You see, these both have the same. Difference is, I have split minus 2x. Minus 4x plus 2x is equal to minus 2x. Same thing coming. Now, in between these two, first two, what is the common? Common is x. If the x common, bracket x minus 4. Again, from 2x minus 8, plus is here, so plus 2 is common in between 2x and minus 8. 2 take common, x minus 4 is equal to 0. So that implies x minus 4 into x plus 2 is equal to 0. So that implies x minus 4 is equal to 0 or x plus 2 is equal to 0. So that implies x is equal to 4 or x is equal to minus 2. So two zeros of the quadratic polynomial a square minus 2x minus 8 are 4 and a minus 2. So find the zeros we have completed. Next is the relationship between the zeros and the coefficients. Now very good. Now you see here, p of x is equal to x square minus 3x minus 8. This is the question given. Now you have to write this one in the form of a general quadratic equation. General quadratic equation formula is ax square plus bx plus c. Now if you write a square minus 2x minus 8 is equal to ax square plus bx plus c is equal to, then equating the coefficients of a square, x and a constant of both the sides of both the sides we get what we get. Now we get x square is equal to x square, so a is equal to 1, minus 2x is equal to plus bx, so b is equal to coefficient of x is equal to b and coefficient of x is equal to minus 2, so b is equal to minus 2 and here constant is plus and constant is minus 8, so c is equal to minus 8. So p of x is equal to a square minus 2x minus 8, where a is equal to 1, b is equal to minus 2 and c is equal to minus 8. Let alpha and beta are two zeros of the quadratic polynomial a square minus 2x minus 8. Let alpha you take 4 because two zeros are 4 or minus 4. So let alpha is equal to 4 and beta is equal to minus 2. Then alpha plus beta means sum of the zeros is equal to in place of alpha at 4 plus in place of beta minus 2. 4 plus minus 2, 2 means 2 by 1 same thing is equal to minus 2 by 1. So one question is coming, why in place of 2 I have written minus 2 because minus 2 is plus same thing, but why I have done like this? Because your b is equal to minus 2. So if I may write minus 2, so in place of minus 2 directly I write b, and here minus will be there. So alpha plus beta is equal to minus b by a. You know the quadratic formula. Sum of the roots alpha plus beta is equal to minus b by a, and a product alpha and beta c by a. So I have to show alpha plus beta minus b by a should come. Therefore I have written like this. Next is alpha into beta. So alpha is equal to 4, beta is minus 2. So 4 into minus 2 minus 8. So minus 8 means same as minus 8 by 1. So what is minus 8? The c. So I can write c. What is a? Is equal to 1 c by a. So like this exercise 2.1 question number 1 first number 1 is solved. And one more question I will do from this question, that is 1.5. Question given p of t is equal to t square minus 15t. So this is something different from that one. So that's why I am solving this one. T square minus 15 pt. Now put just like we have done in that one. Put pt is equal to 0. So that implies t square minus 15 is equal to 0. So that implies you can write t plus square root of 15 or t minus square root of 15 is equal to 0. So where this one came, the formula a square minus b square is equal to a plus b into a minus b. Just you can write this one is equal to t square minus square root of 15 square is equal to 0. So therefore t plus square a plus b a minus b, so t plus square root of 15, t minus square root of 15 is equal to 0. So that implies t plus square root of 15 is equal to 0 or t minus square root of 15 is equal to 0. So that implies t is equal to minus root over 15 or t is equal to, because minus will go to that side, right side plus will go, t is equal to plus square root of 15. So therefore two zeros of p is equal to t square minus 15 are, one is minus square root of 15 and the plus square root of 15. Two zeros we have got. Now the relation. Now put p of t is equal to t square minus 15 is equal to ax square plus bx plus c, just like we have done the first one, because we have to write t square minus 15 in the form of x square plus bx plus c, so that a, b, c we can find it. Now you see t square minus 15 can be written as, how will you write this one? A t square plus 0 into t plus minus 15. You can write the same, this and this same, because 0 into t is 0. So here there is no t. So I can write no t means which is 0? The coefficient of t is 0. So therefore I written 0 into t is equal to s square plus bx plus c. So now this is equal to this. Now equating the coefficients of t square, equating the coefficient of, this you can write t square and write it. Now equating the coefficient of t square, t and constant, we will get what we get. Now a t square is equal to t square, therefore a is equal to 1. bt is equal to 0 into t, so b is equal to 0 plus c, and this is minus 15, so c is equal to minus 15. So we get a1, b0, c is equal to minus 15. Now two zeros we have already got. One is minus square root of 15, another is plus square root of 15, two zeros. So let alpha is equal to square plus square root of 15 and beta is equal to minus square root of 15. Now alpha plus beta is equal to alpha plus square root of 15 plus minus square root of 15, both will cancel, it will be 0. 0 can be written as 0 by 1. So now you see b is equal to 0. So in place of 0 you can write b, and here you can write a, and here is minus 0 and minus 0, same thing. So you can write minus b by a. Similarly, alpha into beta is equal to, in place of alpha, square root of 15 into minus square root of 15. The square root of 15 into square root of 15 is equal to 15. Just like root 2 into root 2, 2. The square root of 15 into square root of 15 is equal to only 15. So minus 15. Now 15 you can write 15 by 1. Minus is equal. Now you see your c is equal to minus 15. So in place of minus 15 you write c, and in place of 1 you write a. Therefore alpha plus beta is equal to minus b by a, and this one is this one. All understood, I think, these two problems, and one more we have to do, that is question number 2. Find a quadratic polynomial Find a quadratic polynomial with each with the given number and the sum and the product of its zeros respectively. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros are respectively. Question number 2, just question number 1, given 1 by 4 comma minus 1 given. Now this is the given the sum and the product of zeros. So the 1 by 4 is the sum of the zeros, means alpha plus beta is equal to 1 by 4, and alpha into beta product is given here minus 1. You have to form a quadratic polynomial. Okay. Now you see alpha plus beta is equal to 1 by 4 given. Alpha plus beta is equal to 1 by 4. And alpha plus beta formula you know, minus b by a. Minus b by a. So if you equate, then what will come? A will come your 4 and b will come your minus 1. A is equal to 4, b is equal to minus 1. Then alpha into beta is equal to c by a. Alpha into beta you are given minus 1, but you know alpha into beta is equal to c by a. Your a is the 4, a is already 4. So how you write this one? Now if I write this is minus 4 by 4, because minus 4 by 4 is minus 1, so minus 1 minus 1, same thing. Now in place of c, you can write equity. Therefore your c is equal to minus 4 and a is equal to 4. So we got a is equal to 4, b is equal to minus 1 and c is equal to minus 4. Now require quadratic polynomial is equal to p of x equal to as square plus bx plus c is equal to, in place of a you can write 4 square plus bx, here b is equal to minus 1 plus minus 1 into x plus c is equal to minus 4, or you can write this is 4s square minus x minus 4. So now this is the question given, find the for the quadratic polynomial. So this is the quadratic polynomial. You see here alpha plus beta is equal to minus b by a. So minus of b by a, so it is coming here minus 1 by 4. So this is coming your alpha plus beta is equal to minus of minus 1 by 4, when minus of plus. So coming this one, and then is your alpha into beta c by a. C is minus 4 by a is 4. So minus 4 by 4 is equal to minus 1. So this is the required quadratic polynomial. So like this, question number 2, there are 6 questions are given. Just like question number 2, number 1 I have solved. You have to solve the other problems. Similar exercise 2.2, 1, question 1, 1 and 5 I have solved. The remaining 1, 2, 3, 4 problems you have to solve. Next class we have to discuss about the Example 9. Find the zeros of 2s square minus 2s4 minus 3 square minus this one. You will know the two zeros. Example 9 I have to solve. Then your exercise 2.3 will start. After exercise 2.3, then your first chapter will over. Second chapter will over. Thank you. Have a good day.